Hello and welcome to this presentation titled Real-Time Logistics Visualizations with Kafka. My name is Fredrik Hilding. I'm 30 years old from Sweden. I work as a consultant in IT for urban development at Sweco, along with many of my other FME colleagues, working both with Workbench, server, cloud, really anything. I think my favorite aspect of FME is both using it and integrating it with some of the software development stuff that I also like to work with. And I think the question for today, it's this old classic. It's 10 p.m. Do you know where your fleet of vehicles really are? Today we will talk about three things in essence. We want to go from Kafka to the map. So this will involve a brief primer on what Kafka is. We will get into the flow a bit and how I've built it with FME. And we will try to provide a real-time view of the situation at the end of the presentation. Because at the core of this, I think it's time to elevate streaming data. So what does that really mean? There's a lot more sensors now and have been added just the last 5-10 years probably. So many organizations are well on their way with data collection and gathering. In this case, for logistics, it's going to be GPS positions. But you can really imagine this being sort of any sensor. And it really doesn't have to be a sensor at all. I mean, anything that continuously produces data ends up somewhere. Well, that's streaming data, right? And I think a lot of this data is being gathered with no plan for what to do with it. So I would say it's well overdue time to start using this for validation and for analysis. So what we will try to do today is to liberate the data from the Apache Kafka system, move it via a platform that we all know and love, and try to put the data closer to where the decisions are made. In this case, a visualization, but it could just as well be really any system, and we will get back to that at a later point. But first, to understand most of what we will talk about today, I think we need a brief primer on what Kafka is. So Kafka is what they call a pub-sub model. Pub, publish, sub, subscribe. In this case, if you're familiar with the FME server old way of doing automations and chaining things, then this is not unfamiliar terminology for you. But we will dig into it a bit deeper. So on the right, you see a sort of a schematic view of what a Kafka system is. And first of all, we have the producers. Anything that feeds data into a Kafka cluster, as it's called, is called a producer. In this case, again, it's the parcel vans with GPS trackers on them, but this could also be a temperature sensor or a checkout line in a grocery store, or really anything that writes something that we want to keep track of. Then we have the Kafka cluster itself, which is the brains of the operation, really. It manages a lot of the things that makes this easier for us as consumers of the data. A topic in Kafka is a bit like a file or a bit like a database. Actually, I think for FME users, this is easier than normal to understand because a topic, it's a feature type, right? It's the smallest part of the thing where you want the data to go. And inside topics, there are partitions, which for this case, we don't really have to care about. It's something that the Kafka cluster uses for load balancing and redundancy and so on. But in this case, we can just imagine that we have one topic, one partition, and that's it. And then at the end, there's the consumers. Well, that's us, right? We want to get the data out of the Kafka cluster and use it for something. So some people would argue that the Kafka file or a Kafka system is a bit like a log file. And you can see how the messages are represented at the bottom left here. And I mean, they're onto something, right? It's just a big list, but it's a pretty intelligent list in this case, because we can read the first 10 messages and then go away and have lunch and come back and then just pick up where we left off. We can also just skip everything we didn't want to read, put ourselves at the end of the stream and just say, okay, just give me what's new. I might have missed an hour's worth of data. That's not important. I can catch it up if I want to, but I can just as well just tell the Kafka cluster, just put me at the end and give me the new stuff anyway. It's fine. And this logic is all handled inside the Kafka cluster. So we as a consumer don't have to do anything really. The brains of the operation takes care of that for us. So if we're getting into the flow a bit here, the most important building block for this operation obviously is going to be the Kafka connector, new since last year, very appreciated on our end. And to use this properly, we have to have, obviously we have to have a Kafka cluster, but let's assume we have one and it's filled with data. What we need to specify is the topic we want to read, what kind of mode we want to use for reading it, and the consumer group ID. So for modes, we can either do streaming or we can do batch, which means we can either catch up or we can just read it as it comes in and so on. The consumer group ID is the unique identifier that we as a consumer use for the Kafka engine to know, oh, it's you, you're back again. Okay, yes, we can continue where we were last time. This would be the starting offset setting. But with all this in place, we can then proceed to, okay, well, what are we going to do with the data? Well, in this case, we want to put it on a map. And there are built-in functionalities in FME server that we can use for this, because one easy way, because we just want to get a point and send it off to the web map in some way. So we will do this using WebSockets, which is a oldie but goldie protocol for streaming data. And you might think, okay, but we're going to read it from one streaming source, the Kafka queue, and then just write it to another streaming source because it's fun. And yes, it is fun. But we can also use two things built in FME here on the way. So both we utilize the fact that the WebSocket server is shipped with FME server in itself. That means no additional infrastructure is needed. Everything we need is already with the FME server that we're going to run this on. Perfect. WebSocket manages messages with, we just send JSON messages. So again, built-in functionality is already there. But the real kicker is, okay, what do we want to do with this data? We can just take everything and send it off. And then you might argue that, okay, but can't you just program this? Can we just put a Kafka reader equivalent in the code for the web map? And yeah, we can, of course. But the upsides of using this in FME is, what if we want to do something with the data on the way? In this case, as you can see on the flow at the bottom, we put a spatial filter there because cars, in this case, they're transmitting their position even when they are loading parcels. And that's not really interesting for us. We just want to see them when they're on their way. So let's assume, for example, that you have a shapefile or a database with the positions of every terminal which they load at. Well, you can take that point, buffer it a bit, and exclude them, use them as a filter for the spatial filter. And that way we have successfully filtered data. So we know that what goes on the map is only the data we care about. We could have also, for example, joined and enhanced this data with some information. It can be really anything. In this case, perhaps it could have been contact details for whoever is driving that specific car that specific day. It could be useful if this was more of a dashboard for the consumer or the customer service rather. So the possibilities, obviously it's FME, so they're quite endless. But this is why we want to put it inside a job running on FME server. So we will try to have a look at what this actually then results in. On the right, you see here what we do with it. This is a snapshot of an earlier day's run with the actual positions of all the parcel vans at that given moment. So this is taken them from a JSON message in Kafka, transformed it, filtered out with stuff we don't need, and then we just send that off to the map. So in this case, we decided that we want to visualize whatever the end result is. But we could have just as well stored this in a spatial database, because then depending on what we want to do with the data, obviously decides the end goal. At the moment, the data is gathered and then never used. So visualizing it obviously helps a bit, but it doesn't help if we want to follow up something up or verify or try to understand something deeper from this quite large amount of data. So let's see if the demo ghosts are with us. So this is actually live view, somewhat sped up since before, and I've taken quite an overview image of the Stockholm area, so you can just see stuff moving. Some of them are moving quite far because they're traveling on roads with quite high speeds. You can see that all the way out on the left, for example, the lone car driving on the island. Or you can have a look in the downtown area where you see more movements, more cars, but shorter intervals, obviously. And some of the cars are stationary because parcel vans, by their nature, drive, stop, deliver, go back, drive, stop, deliver, etc. On the right, you see a slightly zoomed in version, so you can see more of that. The accuracy and the precision in the data is pretty good, actually. Because FME Server 2021 has such excellent streaming support, really, I think there's never been a better time for anyone to decide that, yep, it's time to use my FME Server skills and applications for more streaming support, because previous years it would have been not impossible, but more difficult to get this kind of operation up and running on an FME server. Again, it's really the same thing with the WebSocket. It's an oldie but a goldie. It works for what we needed. It provides us very simple building blocks from going from an FME server to the web map, because all we really need is some example lines of code from the from an open layers application and some JavaScript to read the WebSocket stream. And that's it. We don't have to do anything more on the visualization side. It's already there because so much of the job is done on the FME side already. And then the question is, of course, what do we want to do with the data? Well, the possibilities to store and analyze are, in some sense, endless. It depends on what we want to do with this. In this case, well, let's say you wanted to know how fast you really can drive on a given set of road. Because, well, it has an indicated speed. It has a maximum speed if you want to. But everyone who knows the area knows that, well, you're not driving the maximum speed on that road any time, really. So let's say instead you have a fleet of vehicles that drives past it quite a lot on different times of day and with different amounts of traffic and so on. Well, if you want to, you can really take that data and start building your own ground truth of what this road network can really involve. Or maybe you want to check, okay, but we gave the driver a route. Did he follow this route? Or is there information that they have in the field that isn't in the planning and optimization? Well, again, if the data is already being gathered, it's almost negligent to not build a flow where we can capture this data and use it for some kind of analysis at a later point. So it's 10 p.m. Do you really know where your fleet of vehicles are? I do, but I don't know where they were yesterday. And I guess that's sort of the discussion I want to raise here is, okay, but how can we do more with this kind of real-time data? Is there low-hanging fruit in the organization or in our own organization? Or is it that we don't really know what to collect because we don't really know what we want to do with it afterwards? I mean, it can be a bit of a chicken and the egg problem, right? We don't collect the data because we don't know what we want to do with the data. And we don't know what to do with the data because we don't collect the data. So with this kind of argument, we'll just never collect any data. Or perhaps even worse is the case that, or you bought a lot of sensors to collect the data and you're now collecting the data and it sits somewhere and then it gets thrown away after a while and there's never any analysis done to it. You just have some data. Well, in this case, I think you really have to make it easier for the gathering of the data to also fit into some kind of analysis pattern. Can we just store it in a database for a while? Can we have FME write it to, I don't know, a daily Excel file? It is our favorite format after all. Just something to collect the data so we can start the analysis, so we can do more with it in the future. From me to all of you watching, thank you very much. And if you have any questions, don't hesitate to reach out. Thank you.